Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hi, I'm Lars from the GOTO team, and I'm here in Copenhagen at GOTO Copenhagen. This is a GOTO Unscripted episode where I'm joined by Richard Feldman and Erik Doernenburg. We're going to nerd out a little bit about programming languages, but before we do that, if you could say a few words about yourselves. Maybe you, Richard, first.
Sure. I'm Richard. I work at a company called No Red Inc. We're hiring. So I've done a lot of Elm in my career. So I'm the author of Elm in Action from Manning Publications. Also really into Rust, doing a lot of that on the side because I'm working on making a programming language. The compiler's written in Rust, so I've also done a course on front-end masters for Elm and also for Rust.
Okay. And you, Erik?
So I work at Thoughtworks, a consulting company. I work mostly as a consultant, helping clients make more out of software, write software in new ways, using different programming languages as the client requires, as the circumstances require, and as new programming languages appear.
Okay, interesting. So I wanted to do a fun experiment with you two. At the conference party we had last night, I think you were both there, we had Mark Rendell design the worst programming language in the world by looking at previous languages that do horrible, horrible things and taking the worst parts of all of those and building the worst language you could think of. I was hoping we could do a little bit of the opposite exercise here, where if you were to design your ideal language, what kind of features would you take from where and what languages would you draw inspiration from? I know, Richard, you are working on your programming language, so you might have been through some of this exercise already. Maybe you want to start?
Sure. Well, it's a dangerous place to start because if I'm liable to just talk about it forever. But I'll try to keep it constrained to like what languages do I want to. Well, what characteristics do I want? What languages do I want to steal things from? I mean, take inspiration from. So first off, the prompt was the ideal language. So to me, I don't know that there's such a thing as like one ideal language for like all problems. It's more domain specific. Like if you're building an operating system, I think you want a pretty different language than if you're building like a web server versus if you're building a video game. So embedded systems would be another example. So I've in my career mainly done web development. So let's just maybe keep it constrained to that, or at least for I can start there. So I think if you're doing like web development, there's sort of the front end and the back end. Front end, I'm really happy with Elm, so I'm actually not trying to design a language for web front end stuff. I guess the language I'm working on, if it's used in web development, would be used on the server side. Ideal things that I'm looking for. So I'm a big fan of really ergonomic type checking. I've definitely used languages that have varying degrees of ergonomics around type checking. Some where it seems like it's a net negative, like it's so painful that I would rather not have it and rather have dynamic types. All the way to like Elm has extremely nice, like well-designed type system and really helpful, friendly error messages. So I think that is my ideal. That's definitely something I would take from Elm. As far as like memory management goes, I think automatic memory management would definitely be something I would want. Building an operating system, probably not. Probably want direct control over that. Maybe I can just start with those two, and just so I don't talk forever. What do you think?
Yeah, I'm in complete agreement about the consultant answer. It depends, right? And I don't think you should try to design a language. And it was part of Mark's keynote, was the fun of saying he wants to design a language for everything. And that is, of course, the first mistake you do.
Right.
So I completely agree. It depends on what your target is. I think the memory management, we could even on the lowest level do something like automatic reference counting, or what Rust does with its memory management with the borrow checker. So I think you definitely don't want. Humans have proven over 30 years that we are incapable of doing memory management correctly with all the tools and best intentions. So yeah, give that to the machine. types, I'm similarly conflicted. I've written large systems in I learned last night, gradual typing. I know this from Objective-C, where you can also design types or you can leave them out if you want. In a large team, it is often quite good. In large code bases, it's good to have the type system because it really helps you understand the code better. And most of the time, it's important that you can read the code. Writing is only done once most of the time. Reading is happening often, so types really help. I guess one aspect that you didn't touch upon is this often portrayed divide between object-oriented programming, which was considered the winner until like 5 years ago, and then functional programming. And I think the languages that allow to do both are probably something I would draw inspiration from, or would at least design a language that can use something for very state-heavy things that are based on classes and attached behavior, but also allow you to do something that is more functional, but not trying to say I'm either or.
Gotcha. So I'm definitely on the functional side of things. I spent the first half of my career doing object-oriented programming and the second half doing functional programming, and I definitely appreciate where that let's do both is coming from. But from my perspective, the thing that I like about functional programming is the subtractive aspect about like let's take things away and make it smaller and simpler. And so to me, the like since that's part of the appeal, like constraining it down and just saying let's just do functional and let's have this be like one small set of simple primitives. That's for me like kind of the way to go. That's my ideal.
I'm completely with you. I mean, I have a com science background. I completely agree. I love the elegance. I mentioned it in the talk I did about Rust, that I did the precursor of the implementation I was showing in Clojure, and I enjoyed that actually more. I'm a great fan of Lisp-like languages. But I recognize that there's something in object-oriented programming that appeals to human beings, categorizing, classifying, putting things somewhere. And I think that is hard to get over. And there's one system we wrote for, or with the client. It's a large system, many microservices, and it's not really, the backend is not the backend. The backend is just an adapter over some real backend that can sometimes be a mainframe. And we thought, what better place to use functional programming? Because you're basically transforming what's coming from the real backend to something that goes onto an HTTP endpoint, JSON, to the JavaScript frontend. We chose Clojure for it. And people were not so used to it. They were struggling, and we gave it like 2 years, to be honest with you, on the services. And still, when we then asked the teams, the next microservice, what do you want to write it in? The answer was Kotlin. Honestly, because they were like, yeah, there's still a lot of state, and we want to ship these objects, and it's a sales system. There's a customer object and products, and we can model this in our head, and we understand this, and we know the patterns. And it was heartbreaking for me to see. There was a place where a client didn't object to us using Clojure, where it was really a great area of application, and still, on the whole, the team said the experience was good. But when asked, would you do it again, which is the critical question, they said, no, we choose Kotlin.
That's interesting. I definitely, I know people who have stories on both sides of that, like people who have a similar story where they tried, like maybe in the case of Elm, like they were used to like React and TypeScript. They tried Elm and they didn't like it. They're like, you know what, I want to go back. Or maybe they went in like Rescript or some other slightly more object-oriented direction. I guess some people would argue with me about that, but I think that's accurate. But then I also know quite a lot of people who have the opposite story where, they try it and they're like, I can never go back. And actually that's like where a lot of our hiring comes from, is just people who are like, now that I've had a taste, I can't go back to, not Kotlin specifically, but like, the object-oriented world. I need more of this functional stuff in my life. I want to go back to something you said though, because I think this is a good observation that like humans like classification. That's like kind of a fun activity for us. But something that I was reflecting on somewhat recently was like looking back at my history with object-oriented programming, and I did spend a lot of time on that, and I did enjoy it, but I don't think it actually helped me out that much in terms of my code. Like I spent a lot of time classifying like what is this thing? What should it be? Like what should the taxonomy be? What should the hierarchy be? But in terms of like what did I actually get out of it in terms of like productivity, I don't think it really paid off. So I agree with the point that like I think as humans we like that, but I'm not sure if that means that it should be in the language. Maybe it's like a temptation that's better to remove.
Inheritance is probably a temptation that is better to remove. I mean, you can do object-oriented programming and completely overdo it with inheritance, and that I have seen. And I've seen, isn't everything on an abstract level just something? And you're like, yeah, that's true. But when you write code, you get these really almost empty base classes. There's hardly anything in there, and you're like, why did we even make there a common super type? I get that.
Yeah. Well, I also remember one of the enterprise Java jobs I worked earlier on in my career, and this is more than 10 years ago, but I think this is probably still done in quite a lot of places, was we had a rule on the team that basically is I guess the Liskov substitution principle, always build to the interface and then always only return concrete types, when you need to. So we'd always say we're going to use the list interface for, everywhere, except when you need to actually make one, and then you're going to use array list. The thing is, always did exactly that. We always had exactly list for the interface, and then we always had exactly array list for the implementation. And then wherever we were making our classes, there was also a corresponding rule that you had to make an interface first, and then we would always make an interface, and then make exactly one class that implemented all of the methods in that interface, and then that's what we would use everywhere. And I look back and I was like, well, I know that the principle was, well, this way, theoretically, if we want to, we can swap out the implementation for something else. But I was like, based on how often we did that, which was in the 2 years I worked at that company, 0 times. I think we probably would have been better off if we'd just been like, you know what, let's just assume we're going to pay the price if we ever do need to change this, and we won't have all the interfaces in place. We'll just go through and do the change to switch it from one class to another. I think that would have been much cheaper. And so even without the inheritance, that just seemed like, and this is also not about classification, really just about, I guess, premature abstraction perhaps. But yeah, that temptation kind of stuck with me, and or maybe not temptation, but just thinking about how we can spend so much time following what seems like a nice thing or a best practice, and then being like, but did it really pay for itself? I don't know.
Good point. That brings me to testability. That should be really in the language. And why am I thinking that? Because historically, one of the drivers for this interface implementation separation was testability. And this was, remember, 10, 15 years ago, dependency injection was something new. Right. And people sometimes did this and said, okay, let's separate the interface from the implementation, because then in the test, you only have the interface. You can't instantiate it. Or in your code, you can't instantiate an interface, which means you must declare dependency, and then you force the teams to use dependency injection. So there were some other motivations behind. I'm noticing again, when you do unit testing, you often want to mock the surrounding things. And I've actually written a mock objects framework for Objective-C. And when Swift came out, people asked me, can you make the Swift version? I was like, no, I can't, because I don't have the runtime to do this even. There's just no way that I can do all the trickery in the runtime that I could do with Objective-C. But that means then the interfaces are becoming more important, because then you can stub away and you can do things in your test, in the unit test especially.
Yeah, I think that's a great point about testability in general, and I would take it a step further and say that, to me, any new language, you might as well plan to design the language with tests in mind, because at this point, historically, it seems like most languages were designed where you've got a compiler and we've got a language design, and then there's these ancillary things that everyone's going to do sooner or later, but it's always, for some reason, considered outside the scope of the language, even though you know it's going to happen. Someone's going to write a test framework, there's going to be a package manager, and and now, in more recent years, it seems very safe to assume there's going to be a formatter that's going to format your code in a specific way. I think Go started that, but plenty of languages have picked that up now. And so at that point, it seems like, well, if you know this is going to be done by someone at some point, it seems like you should just design for it. You could do a better job, or make it more well supported if you're planning ahead for it. And yeah, testing is definitely a big one.
This is something we see with Rust, for example. They put the package manager into the language. Not the programming language, but it comes with Rust, right? There's no way to do Rust without the package manager. They put the unit test actually into the same file as the code, so they really thought that through. Yeah, that's definitely the inspiration to take from. It should be testable. I think in this day and age, we really have to have a language where you can write unit tests, because we know that we are writing increasing amounts of code that stays around for a while. We talk about shifting away from projects to products, these services we expect to live for a while. And if you don't write tests, you might as well give up, I guess.
Yeah, they're definitely indispensable. Can't do without them. Okay, I want to go back to memory management for a second. So, because you mentioned Rust, and so I think we agree that, at least for the types of problems we're talking about solving, we're probably want to go automatic memory management. But there are a couple of different ways of doing that. So you mentioned automatic reference counting, or Rust has the ownership system, so it's just freeing and allocating things on the fly. And then you have the most popular, which is tracing garbage collection. To me, of those three, tracing garbage collection is the least appealing, even though it's the most popular, just because you have GC pauses. And I know that JVM and Go have spent a lot of time decreasing pause times, decreasing latency and all that stuff. But it still seems like, at the end of the day, you just don't have to worry about that problem if you can do automatic reference counting, or allocating and freeing on the fly like Rust does. But then there's always the question of latency versus throughput. And, supposedly tracing GCs have the highest throughput over a given period of time compared to automatic reference counting and so forth. But I'm also aware of some research, and this is, spoiler alert, in the language I'm working on, we're going down the automatic reference counting route. But you can do stuff like compile time reference counting, where you can detect that, there's going to be an increment here and a decrement here. Those will just cancel each other out, so we're not going to do either of those. So it's hard to say in practice. Like, we haven't, the language is called ROC, R-O-C, but roc-lang.org. And we haven't gotten any big enough projects yet, because it's a very work in progress, very early stages kind of thing. We haven't gotten a big enough thing that we can really definitively say yet. But so far, it seems like the frequency with which it's possible to use these papers and these techniques that we learned to do this compile time reference count, it seems like quite a lot of the reference counts can be elided. So we'll see.
Yeah, my impression was also the tracing garbage collectors just work. I mean, there's a lot of theory behind it. You can get a reasonable implementation work. You have long pauses, but in some cases it doesn't matter so much. And I think it is exactly like you said. The research has gone further now. So understanding this, and I mean, Rust didn't invent the borrowship or this concept, but they were the first one to get it actually implemented properly.
Right.
And I think what we're seeing now is that a lot of the concepts that are somewhere in the middle between no memory management and the tracing garbage collectors, which they're like a blunt tool, if you will, right? You know they work and you can't make a big mistake. And we're exploring the middle ground now. And I think we will see more and more successful languages in that middle ground. On the performance, I'm curious. I mean, I know all the theory in Java about the different generations of objects, and most objects are thrown away. Again, if you're writing websites, probably most of the objects are there just for a brief moment in time to create the response. You can throw them away. You don't get heap fragmentation like you would in other languages, but sometimes you can compact the heap. I think that there's room for experimentation, and I think there's enough systems that will be, for the programmers, they'll be happy if they don't know. I mean, if you can't tell whether you're using a tracing garbage collector or automatic reference counting or something similar, as a programmer, you don't care, and you probably choose the language based on other features, but if the language doesn't have to use a tracing garbage collector, it's probably better for you.
Yeah, two interesting areas of research around that. So compacting, there was a really cool talk at Strange Loop a couple years ago called, I think it was called Compacting the Uncompactable. And it was basically about how they designed an implementation of malloc that actually can do compacting. Really impressive stuff. And they were using some very fancy tricks to make that happen. But of course, an automatic reference counting system could use that. And then the other is throughput of automatic reference counting versus tracing GC. Apparently, Apple is, because Swift does automatic reference counting, they're actually working on, at the hardware level, making that faster and adding I don't remember exactly what it was. It was some sort of either a new CPU instruction or augmenting existing CPU instructions for atomic reference counts to make them faster. And that's definitely an interesting sign of potential things to come, because if you think about it, you have this big company that's really heavily invested in not only in Swift as a language, but also in making their own hardware. That's the type of thing that can influence other processor makers to try and keep pace with what Apple's doing. And so if Apple's making hardware level optimizations for automatic reference counting, but not for tracing GC, or I don't really know what that would look like, that's an interesting potential thing to keep in mind, that even at the hardware level, there might be potential improvements, even if the software algorithms say the same.
Yeah. And Apple is motivated. I mean, they have tried. They have tried garbage collectors. They tried the whole Java interop. They tried to have a garbage collector for Objective-C, and they really concluded that for their use case, it didn't work. So they are very, very motivated to make automated reference counting work. And I mean, by all means, it generally works. I mean, there's probably slightly more cases where you can have errors of cyclical dependencies and holding on to each other. You can still create the same problem with the tracing garbage collector, though, if you just have a static variable somewhere where you store something. But on the whole, I think they will make it work. And like you said, I mean, if they can reduce the performance impact at that level, then there's very little that stands in the way of doing that more widespread.
Yeah, interesting note about cyclic dependencies. This is one of the reasons that we decided to go with automatic reference counting, is that so ROC is a pure functional language, and it's actually, because there's no semantic way to express mutation in the language, there's also no way to create cyclic data. So we don't have to worry about that at all. But that's unusual. Only if you're, only if you've subtracted that much from the language can you get away with that.
What kind of concurrency model do you think would be a good fit for the ideal language that doesn't exist?
I don't think I can explain that in the context of ROC without going on a really long tangent.
So I come from Elixir, and I think that has a really great concurrency model, and it's sort of building upon the past in the sense that it uses Erlang as its foundation, and Erlang was sort of building for the telecom systems where when you're on a phone call, it should be invisible to the user that, oh, now you're actually going through that cell tower, not that cell tower. So in a sense, it's very good for distributed systems. And as a programmer in the language, it's almost like it's incredibly easy to write concurrent code. It's all built in. It's sort of by default, you don't really have to think too much about it. And like running a piece of code on this computer versus running it on another computer across the world over the internet is extremely similar as a programmer. You don't have to jump through a lot of hoops to do that. The beam takes care of it all. As long as you have those nodes clustered together in the same cluster, it's a matter of just telling, hey, the other computer, run this code, please, and it does that. And I think that's a really powerful model.
Yeah, so I think Erlang's an interesting example of like a domain-specific language, because the concurrency model that it has. Now, personally, I've not actually like written a line of Erlang or Elixir, but my understanding from like reading up about it and talking to people is that it's basically like a message queue-based system, and so you can pass messages between different. They call them processes, but what they mean is sort of like. I don't want to say threads because they don't map to operating system threads, but thread-like things, perhaps. And then basically the message queues are automatically sort of handled by the runtime, and since it's all immutable, you don't have to worry about things like data races and stuff like that. Mm-hmm. So that makes a lot of sense for a lot of use cases, but I suspect that, for example, somebody who's thinking about concurrency in the context of making like a really high-performance game, they're a lot more concerned with A, single-threaded performance, and B, the overhead about communication. They probably actually want to do like mutexes and locks and like direct mutation of things. And even though that's a more error-prone concurrency model, it also runs faster, and they're probably a lot more concerned with that. So I think again it kind of comes back down to use cases. So if you're focusing on like distributed systems like servers specifically, I think it's like. That's a great model for concurrency, but I don't know. I guess it depends on what your ideal language wants to be ideal for.
Yeah, I guess it's all a trade-off, right?
Yeah.
I think I agree with the idea of having in Go. I think they're called channels or something which makes it easy to shift data from one thread to another. Mm-hmm. To build that in, Rust has something similar. The languages are doing that. I think though sometimes this. Parallel programming is overestimated. I mean, we don't see these massively parallel computers that people talked about like 20 years ago. I mean, we're seeing more cores now. We're seeing like 20, 30, maybe even 60 cores. But let's go to 100. For most cases, and like you said, in video games and so on, for most cases, you don't have a single application that does one task and needs to utilize all the cores for it. Maybe on the graphics card and so on, but not for the processing itself. So what we often find is that you need parallel computing in server applications where you are servicing multiple parallel requests, and then it becomes very easy, right? If you have a web server and you have 1,000 concurrent users and you have 1,000 threads, question is, should you do that from a throughput perspective? But you have 1,000 threads, then it's very easy. They just shouldn't get in their way. You should have something to make the threads isolated. But to have this thing where all the threads communicate all the time. I mean, I mentioned this in the Rust talk. In the simulation, it didn't even make sense to break it up into multiple threads because the communication overhead was so big, and the calculation then became completely background noise in all the communication between the threads that I didn't get a speed up.
Interestingly, so one form of parallelism we haven't talked about is sort of like really low-level data parallelism, like on the CPU, like SIMD. It seems like there actually have been a lot of advances there in terms of like SIMD JSON is like several 100% faster than like other JSON, like really highly optimized JSON parsers that don't use SIMD. But the algorithms are completely different. It's like I started reading the paper on that, and it's just like it doesn't even look like parsing anymore because it's just so completely different what they're doing. But it runs way faster because they can do like 8 to 16x the amount of work at once. But that's I don't know if that's something that at least currently they're like really good language level abstractions for. Like I don't even know how you would design an abstraction for that. That's like other than just saying like, well, maybe the optimizer can recognize that like we can SIMDify this chunk of instructions. But it doesn't seem like I would love to steal something from a language where it's like, oh, this is like Erlang's is really great for like servers this style of concurrency. Is there some similar thing for expressing like SIMD, like algorithms like SIMD JSON in an abstract way, so you don't have to, get as low level about it? I'm not aware of it. Maybe someone will come up with it, but I just don't know.
Yeah. Are there any I mean, you both seem excited about Rust right now, but are there any other languages you see sort of on the horizon that are up and coming, very early stages that you think look interesting?
Absolutely.
I've just heard about one, Rock.
I wasn't going to say Rock. I was going to say Zig.
Okay, I haven't heard about Zig. What's that about?
So Zig is, I would say, approaching the same problem domains as Rust, but coming at it from a very different angle. So having used both languages, I would describe, and also we actually use Zig and Rock for the standard library. So the standard library in Rock is implemented in Zig. So I think if I were to pitch Zig, the way that I would pitch it is it's basically like, let's take C and let's keep the simplicity and the sort of like bare bonesness, but let's add ergonomics on top of it, but without adding a lot of complexity. Rust is like, let's try to make a completely different language from C. Any amount of complexity is acceptable as long as we have these really strong guarantees about memory safety, about if it compiles, it's probably going to work, and really, really strong guarantees. So Zig is definitely less on the side of guarantees, but very much on the side of ergonomics, and especially in terms of speed for the developer. So like the Zig compiler is extremely fast. Like it runs super, super fast. The Rust compiler is extremely not. I mean, that's like my number 1, number 2, number 3, and number 4 and 5 and 6 complaint about Rust is compile times. Just like how long I spend waiting for it. Not the case with Zig. It's like really fast. And they're working on like hot code loading for a C-like language, which is ridiculous. And it like Zig also cross compiles anything. So on my Mac, I can compile a Linux binary and a Mac binary and a Windows binary. Don't even have to spin up a VM. There's just all these little things that, and I can't do that in Rust either. So if I were to make a Venn diagram, it's like, well, both of them can get really low level about memory management and things like this. Zig does not have the borrow checker, so it does not have the guarantees about memory safety, which I definitely, very much value from Rust. But whenever I'm sitting there waiting for Rust to compile or being like, how are we going to build Rock for, Windows and Linux and all these things? And I'm like, well, wouldn't it be nice if I could just actually cross-compile to it? So, as an up-and-coming language, like Zig is much younger than Rust. But I can definitely see a really strong appeal. Personally, my prediction is that Zig will probably outcompete Rust in the specific niche of people making games. Because I think if you're making games, you're probably going to have to do a lot of memory unsafe stuff anyway. This is like my impression as someone who does not make games. But it seems like just to squeeze out every last inch of performance out of a game engine or something like that. I'd imagine if you're writing Rust, you're writing using the unsafe keyword a lot. At which point, it's like, well, why don't we get all these ergonomic improvements too? Especially because games also have a reputation for like crunch time and spending a lot of time, waiting for a compiler. Like really kind of adds up. So. But I don't know. That's time will tell. But
okay, that sounds interesting. Yeah. I'll keep an eye out for that. What about you, Erik? Do you have any up-and-coming languages you're excited about?
Yeah, curiously not really, to be honest with you. I mean, Thoughtworks, as a consulting company, we work with a lot of companies, usually in the enterprise space, consumer-facing websites, internal systems, and so on. And we often, that's part of our culture. We really look at new things. We always try to find new things. I mentioned this system that we were beginning to build in Clojure. And we've tracked a lot of different programming languages over time. And there was really like 5-10 years ago, there was this wave of new programming languages, a lot of exploration, a lot of excitement. But from our perspective, it has really, really settled down. I mean, there's in the web browser at the moment, there's a clear, from our perspective, winner in TypeScript.
Yeah.
That's what you use. And on the server side, as I mentioned, Kotlin is the one that most teams really find a good compromise. It probably doesn't win in any category, but it seems to be a really good all-round compromise. That said, I am curious to see what will happen in the web browser with WebAssembly. Because, I'm making no secret, I'm not a great fan of JavaScript or TypeScript. And I think we even had talks here at GOTO Conference talking about how even the original designers of JavaScript said they would have liked to do a better job of it if they hadn't been pushed to do it in like a very short amount of time. And we're still settled with it. Still, by the way, even in JavaScript, you do see this move towards more functional programming, by the way, and even like big frameworks like React are moving that way and so on. And it's still under the hood, it's JavaScript, and there's reason for all the jokes about JavaScript, about how the inconsistency and so on. It featured quite heavily also in the party keynote. So I've been waiting for a proper replacement, and the transpilation approaches weren't that successful. I think, Dart is sometimes mentioned, but I don't think you could get it into all the different web browsers. So I'm curious to see what will happen with WebAssembly, and we'll see what we what new programming language will emerge to write web applications. Not writing video games that run in a web browser, but something to replace what we currently do with TypeScript. I'm looking forward to that.
Okay. Yeah, I mean, I think WebAssembly is really interesting because we've had a long period of time where if you wanted to run in the browser, JavaScript was your only choice. But I guess we're getting close to the point where you can use whatever language you prefer if the community supports it and builds the tooling for it, right? So that's going to be interesting to see in the next few years.
Yeah, we've had first engagements with clients where people are using Blazor, which is an implementation of C# and the corresponding tooling and frameworks. I mean, it still has like first load times. You wouldn't use that on a B2C website. But I mean, that is a first promising sign, I think, of a more modern and better designed programming language that can actually run inside C#, I'm talking about, that can run in the web browser.
Yeah. And Elm cross-compiles to JavaScript, right?
Correct, yeah.
Or compiles to JavaScript.
It's theoretically possible that Elm could compile to WebAssembly, and Rock actually already does compile to WebAssembly. If I were to make a bet, I would bet that I don't think WebAssembly is going to change much when it comes to web applications, at least not in the next decade. Maybe it's hard to predict further than that. I think it's mainly just going to be games, to be honest, and a lot of thoughts about why, but one of the big ones is just that I don't think that people care that much about performance in web applications. I think it's sort of close enough, and if you and one of the reasons I think this is that the first time Elm released benchmarks was hey, look, we're faster than all these JavaScript frameworks, faster at rendering, smaller asset sizes. There was this real world app which is 4,000 lines of Elm, and it's it's an entire medium clone, not an entire, but whatever. It's a substantial application that does a lot of stuff. Compiled, it's smaller than just React, that entire application, right?
Yeah.
Evan spent a lot of time making really small assets because everybody was oh, we got to decrease our bundle sizes. Nobody cared. And then Evan did a bunch of work optimizing the rendering. It's look, we're faster than React and Angular and Vue and everything, right? And again, people are okay, that's nice. So the idea that oh well, now that we have WebAssembly, we can finally do even better than that on performance. I don't think that's the real pitch. I do think there is definitely a potential pitch for well, now you can use whatever language you want. You can use C#. But the thing is, we've already had stuff like Scala.js. I know one team that's ever used Scala.js, but there's tons of people using Scala on the back end. So is that really the issue? Is it the lack of speed in the front end? And there was GHC.js for Haskell, which I guess had a lot of performance problems. But I guess it seems to me that has been done before in the compile to JavaScript thing, and I'm a little bit skeptical that the only missing piece was if only you could compile to something closer to machine code, then it would be fine. I think it's really just that JavaScript and now TypeScript has this huge cultural momentum, and if we look at what's been successful in terms of mass popularity, it's really been JavaScript, CoffeeScript, whose tagline was "It's just JavaScript," and TypeScript, whose tagline is "It's just JavaScript," and that's it. Those are the three big success stories, and everything else, Elm and whatever. Elm is actually the most popular, widely used compiled to JavaScript language that's not TypeScript, at least according to the State of JS survey. But it's a very, very distant, below TypeScript. So I think the real issue there is just that there's this huge ecosystem, there's this huge cultural momentum, and all this drive to do that. That even though everybody complains about JavaScript, it's still going to be, I think, it takes something more than WebAssembly to change that cultural momentum.
I get what you mean. And by the way, CoffeeScript I don't think is really a strong contender anymore these days. Even
not anymore.
But what I think is, I agree with you on websites, on what we would consider a website or a shopping website or a banking website and so on. What we also see is there's a lot of internal IT systems. One I mentioned earlier is a sales system that is used by sales representatives, thousands of them, and they're installed. It's downloaded in the cache, of course, of their web browsers on iPads or Windows machines. And I think there, and this is probably no coincidence that it's Blazor and C# that is the first one that we are seeing making use of WebAssembly. I think there's still a ton of developers out there who are used to writing applications that are used in-house. And they have so far, they've tried React, and React is, it has a learning curve. And then people were told, don't use this, use Angular. And then they go, which one are you using? And they say, no, forget about this, let's use Vue. And they were a bit confused about this. And also JavaScript is not a productive programming language. And I think what you will see, that's at least my prediction, that big companies like Microsoft, they have something to gain here. And I think C# is already spreading more on the server side. You can run it on operating systems other than Windows. And that whole idea that you can stay within one ecosystem will put some extra weight on it. I think performance is a hygiene factor. It can't be slow in the web browser. But I don't think you win this because you say we are faster than the most optimized JavaScript. But if it's fast enough, and you have a different story, like saying, look, there's these component libraries, you can write C#, which is a better language, you can use that on the server, you can use it in the browser. Because frankly, we've seen the other trend, people saying, oh, we all know JavaScript, we run it in a web browser, and therefore we write the server applications in Node.js. And that really has some really terrible consequences, I would say, from a performance perspective, from security and so on. So I think maybe you get different dimensions in this world of in-house applications in large organizations that will jump on that more. But I agree, if I were a startup that builds a B2C website, I wouldn't bet on WebAssembly either.
You make a great point. Yeah, I was surprised to learn how big there's this sort of like hidden market of people doing like really big in-house teams. Like I talked to a guy who's an Angular consultant, and I was like, where are all the Angular apps? Like everybody I talk to does React. That's it. Like it's all React, and like whenever people are coming to Elm, they're coming from React. And I was, because I'm in, like you said, the B2C startup world primarily. And he was like, oh no, all of my consultants are like 400-person teams that only build software that's only used inside that company. Exactly. And I had no idea that there was so many of those. But it's apparently, it's a huge thing. You would know it much better than I would. But yeah, that's a really interesting perspective. I hadn't thought of that.
Well, thank you so much for spending some time chatting with me. That's been a lot of fun. I feel like we could have gone on for much longer, time permitting, but it's been a pleasure hosting you. I hope you enjoyed it.
Yeah, thanks.
Thank you.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.